So for our second example, suppose you drive to a toll plaza and find booths with attendants where you can pay by cash or card.
Has anybody got a dime?
I don't have a change.
Somebody's got to go back and get a shitload of dimes.
With that option, the toll is $4 per time you cross the bridge. The attendant gives you the option of buying a decal for $20, where if you get the decal, you get 25% off at each crossing. What we want to do is find the number of times you'd need to cross in order for the two options to cost the same. So again, like with that last example, and like I said earlier, with these problems, the hard part's not going to be the math, it's going to be figuring out how to do the math. To get to the point where you're able to do the math, that is. And that first step we have to do, in terms of setting up our basic unknown, is really, it comes down to identifying what comes up the most often. What thing do we need to know that gets mentioned the most? That's probably going to be a good indicator here. Where in this case we talk a lot about the number of crossings in terms of the cost for two different options, and you know, compare those, so it would make sense to make x equal to a number of bridge crossings. Then, when we have our number of bridge crossings set up, if we have any other variables, the only thing we can talk about really would be the total cost. That is the cost for a number of crossings. But we don't actually care that much about that value insofar as it's a means to an end to get us to talk about when those two options are equal. That is, think in terms of a financial math verbiage, the break-even point, where in one case we're paying $4 per crossing, so it would be 4 times the number of crossings x, or we can pay $20 and 3/4 the remainder after you get a 25% discount of that $4 cost. So 20 plus 0.75 times 4x, or if we're looking for when they are the same, the number of crossings it takes to make them the same, we set them equal to each other. Where from here, the first thing I would want to do is just get rid of that 0.75 and multiplying it into the 4. So we would have 4x equals 20 plus 3x. Then subtract over the 3x to get the x's alone. 4x minus 3x. I'm going to be an extra detailed there, but that's a pretty simple one. You're just left with x is equal to 20. And to check that, to be sure, we can think about what happens with each of those costs. That it says after 20 trips they should be the same. Well, if you take 20 trips at $4 a trip, that's $80. And if you take 20 trips at $3 per trip, that would be 60 plus 20 is 80. So after 20 trips, they would even out as expected. And we're going to keep the train rolling, although not over bridges, and look at another problem like this.